Welcome back to the GCSE Maths Pro YouTube channel. In today's video we're going to be looking at a few different topics that you can learn to gain some easy marks in your exam, and this is specifically for foundation tier students. So here's the list of topics that we will be briefly looking at in today's video. If you're doing higher tier you will need to know all of these as well, so definitely check out this video and then also check out part 2, which will be higher tier content only. So first of all, what is the difference of two squares? Well, as you can see here, we've got an expression that is x squared minus 16. First of all, x squared is a square number, isn't it? It is literally x times x, which is a square number. And 16 is also a square number, isn't it? It's 4 times 4. So those are the two squares, right? We've got a square here and a square here. And then a difference is always subtract, isn't it? If you want to work out the difference between two numbers or whatever it is, you're going to subtract them. So this is the format of the difference of two squares. And I tend to see a lot of questions like this, literally like 2 marks in an exam, but it's just so easy to pick up these marks because it's not even anything to do with trial and error method or splitting middle term or anything really. It's not even really a method, it's just kind of knowing what to do and you can just write down the answer immediately. So this is still a quadratic, however you can see that we are missing the middle bit, aren't we? Normally our quadratics are in the form of ax squared plus bx plus c, and that's what we've been factorising, isn't it? They need to multiply to make c and add up to make b. Well, this is kind of true as well. It's just this one is x squared plus 0x minus 16. Okay, so it does technically have the middle part, but obviously we don't write it because it's just 0. But what we're saying is that the factors have to add up to make 0, or effectively cancel each other out. Okay, so I've obviously gone through kind of the background explanation, but my point is if you can recognize this type of quadratic where you've got ax squared minus c, you can still factorize it into 2 brackets. You just have to recognize that they're both square numbers. You need to do 2 brackets, one a plus, one a minus, and just the square root of each of these. So obviously the square root of x squared is x, and the square root of 16 is 4. You're not even having to really think about trial and error or anything. Obviously I've just shown you how it works, but my point is if I saw this question, immediately I'm thinking, right, x plus 4, x minus 4. I'm not even having to actually work it out, if that makes sense. Identical brackets, but one's plus, one's minus. Now, I want to show you a few other questions which are a little bit trickier. It might kind of throw you a little bit, right? Because you're looking at this going, okay, yeah, we've still got that same situation of like ax squared minus c, but is it the same because I've not seen it with a number in front of the x squared before? Yeah, it's the same. Obviously, the number in front of the x squared also has to be a square number though, right? So in this case, I'm still going to do the same thing, square root the whole of this, which is obviously 2x, not 4x squared, plus square root of 9 is 3, and then 2x minus 3. It still works. Because I don't know if a lot of people know, but 2 square numbers, obviously 4 is a square number, and x squared is a square number. When you then multiply those two together, the answer is also a square number. Okay, now I want to highlight a very similar question again, but slightly more difficult. So you're probably looking at this and you're thinking, right, well, yeah, okay, it kind of looks like the same situation, ax squared minus c. However, then you realise you look at the 2 and you go, well, that's not a square number. And you look at the 98 and you go, well, that's also not a square number. This is what I would call where they have kind of difference of two squares but hidden. They've kind of disguised it. The other thing is to really pay attention to the language that they put in the question, because you can see here it doesn't just say factorise, it says factorise fully. Now, 2 reasons for that. One, because you could probably see, oh, I could just pull out 2, and you might just then leave that as your answer. When it says factorise fully, it normally means there's like 2 steps to factorising it. Obviously, all of the other difference of two squares questions was basically just 1 step, wasn't it? So I just want you to be aware that they might have difference of two squares, but they might have kind of disguised it by multiplying it by something that's not a square number. So what I mean by that is in this case, I need to pull out the 2 because that's hiding everything. So first I'm going to pull it out as single brackets. I've got 2 on the outside and then x squared minus, and obviously 98 divided by 2 is 49. Now some people would just factorise it like that and go, oh yeah, I've pulled out the common factor, like that's all I can do. Okay, yeah, 1 mark. But this is a 2 mark question, right? So what we want is then to go, oh, okay, now I can see this is clearly difference of two squares. I just happen to have a 2 on the outside, which is fine. So when it says fully, that was step 1, but then you need to go, oh, okay, yeah, now I can do the same as before, where it's going to be x plus 7 and x minus 7. A lot of students find it quite tricky to see how error intervals is its own topic compared to upper and lower bounds, but also the fact that sometimes it does seem like basically the same thing. So we're going to go through two different types of questions. One type is where error intervals is effectively the same idea and the same concept as upper and lower bounds, and then the other type where it is slightly different. So first of all, interval is just a range. So your answer should always be in the format of kind of like an inequality. What's the smallest value it could be and what's the biggest value it can be? You write it as a range with inequality symbols. Sometimes the exam will give you the answer inequality already written there. You just have to add the numbers. Sometimes it will be blank and you have to figure out how to write it down. So the first type of question we're going to go through is a question where it's very, very similar and pretty much the same concept as upper and lower bounds. So for example, we have here a number, x, is rounded to one decimal place. The result is 2.7. Write down the error interval for x. So what that means is we've got a number, we don't know exactly what it was originally, but we know that when they rounded it to one decimal place, it gave them 2.7. When we're rounding to something, the original number might have been slightly lower, or it could have been slightly higher. We don't know if they rounded up or if they rounded down. So this is where it's very similar to upper and lower bounds because we're trying to find effectively what's the largest value it could have been to still be rounded down to 2.7 and what's the smallest value it could have been to have been rounded up to 2.7. So we are effectively finding the upper bound and the lower bound. We're just going to write it in the format of an error interval. So 2.7, if we think about it to one decimal place, we're looking at 7. And the way I normally do it when I'm looking at upper and lower bounds is I tend to draw a number line to visualize it. I put 2.7 here and we go, okay, it's to one decimal place. So what's one above, or one decimal place above is 2.8. What's one below? 2.6. Now obviously if it's 2.6, you're not going to round it to 2.7, are you? So what we actually want is halfway between these two. So for example, 2.65, anything 2.65 or above would round up to 2.7, and then 2.75. Anything 2.75 and below would be rounded down. Now this is where it gets tricky because you're probably thinking, well, it can't be equal to 2.75 because that would round up to 2.8. And yeah, that's true. But we also aren't going to want to write 2.749 because technically it could be 9999 forever, couldn't it, up until infinity. And if you just write 2.749, well, what about 2.7491? That would still round down. Or 2.7492 or so on. So this is where it's a bit easier having an interval because we're going to use the inequality symbols. The smallest value it could be is the 2.65. So it can be equal to that or greater. So we have to put the symbol facing towards obviously our x. In this case, just copy the letter that they've given you, but it could also be equal to that. However, the next inequality symbol can't have the equals symbol. So I am going to use 2.75. However, what I'm saying here is it's anything less than 2.75. Not literally 2.75, but anything less. This is how you write the interval. The bottom one will always be less than or equal to, and the top one will always just be less than. Use whatever letter they've given you, and then you have to figure out what's the smallest possible value, what's the largest possible value. So in this case, it is basically upper and lower bounds, isn't it? This is the lower bound, this is the upper bound. We've just written it in an interval format. So those were the first type of question for error intervals. That's where it overlaps with upper and lower bounds. If you have something that is rounded to whatever, decimal place, meters, millimeters, centimeters, whatever it is, that is the same as upper and lower bounds. The next few questions are going to show you how it actually can be different to upper and lower bounds, okay? This is the other type of question. So this might be a new word for you. If you have a look here, you might not recognize one of the words, and we're just going to go through what that means before we actually work out the error interval. You can see it's still written in the same way, okay? It's still the same interval, but it's a different type of question. So a number, y, is truncated to one digit. So what do we mean by truncated? A lot of people probably haven't ever seen this before. And if you get this in the exam and you've never seen it before, well then there's not a lot of hope, is there? So truncated just means we had a number and we literally at some point we just cut off the rest of it. So it wasn't rounded to one digit. It was just whatever was there, it was cut off after one digit. This is still 6 in terms of 6 in the units column, right? So we don't know what the number was. For example, this is just an example, it might have been 6.2357. We don't know. What truncated is they just went, oh, one digit, okay, that's a 6, cut off the rest. It could have been 6.9999 forever, but truncating, you would just cut it off. So it's not rounded up or down. The 6 was 100% there, we just don't know what followed the 6. Okay, so in this case, it's not like it could be 5 point something. No, it was definitely 6. We just don't know what came after that. So if you have a question like this, where it's been truncated, or you get the idea that the number was just cut off after a certain point and you don't know what followed it, the number they give you will always be your smallest value. We don't know, it might have been 6.0. It could have been, couldn't it? And they cut it off. So 6 is your smallest value, okay? So whatever they've given you here in the question, that's going to be the smallest possible value. So at least that's quite easy. Half of the work is already done for you. But then trying to figure out, well, what was the biggest value? Like I said, it could have been 6.99999 forever, couldn't it? Now, it can't be 7 because we know for sure, the fact that it was truncated, we know 100% it started with 6. We just don't know what followed. So the maximum is technically 6.9 recurring, isn't it? 6.9 forever. But the same as before, we're not going to put 6.99, you can't write that many 9s. It's literally to infinity. And you can see we've still got the same inequality symbol. It's not equal to this value, but that's the biggest, as in just a little bit less than that. So in this case, obviously we know it can't have been 7. However, it could have been anything slightly less than 7. So that's why it's not equal to 7. We know that the number was somewhere between 6 and 6.9 recurring to infinity. So I'm going to use 7 for simplicity. So truncated is where they've just taken a number, they've cut it off after a certain number of digits. They haven't rounded up, they haven't rounded down necessarily, they've just cut it off. So we don't know what followed. This question is still the exact same concept as truncating. It's worded differently, and I've seen this a lot with edexcel particularly, but the idea is still the concept of truncation. So we're still on that second type of error interval question. We've just worded it differently. So the number on a calculator display began 5.2 something. Complete the error interval. So what we're saying is if you imagine your calculator, it physically said 5.2, but we don't know what came after that. Could have been another 10 digits. We don't know what followed that. But we know for certain that this is what it started with. So the smallest it can be is that number, isn't it? 5.2. It can't be 5.1 something because we know for certain that we saw 5.2 on the calculator. We just don't know what came after the 2, if anything really. So the smallest is 5.2. Can be equal to that, it can be more than that, but up until what point? Well, effectively at the point where it then becomes 5.3, because again, we know it was 5.2, it definitely wasn't 5.3. However, it could have been 5.299999. Again, we're still into that recurring 9 into infinity, aren't we? So it could be equal to this, but therefore the biggest value is 5.3 here. It's not equal to 5.3, but it's just anything less than 5.3. So it's somewhere between 5.2 and 5.3. So the first bit is to understand how a column vector is laid out and how it works. So you can see an example here. We're told that A is the vector minus 2, 3. So we've got a number at the top and a number at the bottom in brackets, creating this column. The top number means how far we're going to move left or right. If it's a negative, we're going to move left. If it's a positive, we're going to move right. The bottom number is therefore up or down. This one's pretty self-explanatory, so obviously if it's positive, you're going to go up. If it's negative, you're going to go down. Column vectors can be drawn as actual vectors on a grid. They don't have a position in terms of coordinates. There's no actual position. You can draw it anywhere that you have space on a grid, but you just have to make sure the number of squares left and right and up and down are correct. So for this vector A, we've got minus 2 at the top. That means I'm going to move 2 to the left. And then it's 3 positive at the bottom, so up by 3. Then we just connect these 2 points together with a diagonal line. So that's the basis of how column vectors work. Okay, so for this one we've got another pair of vectors A and B. A is minus 1, minus 5, and B is 3, minus 4. So part A is to write A minus 2B as a column vector. So this one's actually combining those past few questions together. We've got a subtract, we've also got a multiple. So for this one, I would normally write out A just because it's still itself, isn't it? Just 1A. Subtract, and then I would work out 2B, so 2 times both numbers in B. So 2 times 3 at the top is obviously 6, and then 2 times minus 4 is minus 8 at the bottom. Now I can go ahead and subtract. Again, with the same with adding, we're going to subtract the top 2 numbers and then the bottom 2, and just deal with any negatives as you normally would deal with negative numbers. So at the top we've got minus 1 take away 6, so that's going to be minus 7. And then at the bottom we've got minus 5 take away minus 8. So here we've got a double negative with the take away minus 8 part. So it's actually minus 5 plus 8 effectively, isn't it? So that would be positive 3. So we've got minus 7, 3 for part A. Then as you can see, part B is to draw the vector a minus 2b on the grid, so drawing the minus 7, 3 on the grid. So minus 7 means we're going to the left by 7, and then 3 means we're going up by 3. So that's our line. It's obviously important to point the arrow in the correct direction. Because we're going up and we're going left, we're going to be pointing the arrow this way, aren't we? So that is a minus 2b as a vector. We're starting off with linear simultaneous equations. So it says, using the graph, solve the simultaneous equations. They list them here. They're both drawn for you, right? You've got each equation is each different line on the graph. And normally this will be a couple of marks and they won't really give you any space for working out. Okay, so the two hints here is the fact that it says using the graph and the fact that on your actual exam you won't see much space to do any working out. So if anything, we don't really even need to look at these equations for this one because it's already drawn for us. All we need to do is look at the graph. Now, simultaneous equations, we've said before, is where you have the x value for both equations is the same number. So we're trying to find what is x. Well, it should be the same number for both equations. And the same with the y, okay? The y is the same number for both equations. So x is the same here, y is the same here. Now, if you think about the graph, we're basically therefore looking at somewhere on the graph where both lines share the same x and the same y values. Now, it has to be at the same time. So really, the main thing about this graph I'm looking at is where do they intersect? Where do they cross over each other? Because that point, exactly in the middle here, is where they both share the same x coordinate and they both share the same y coordinate. Okay, coordinates, values, same thing, right? They're still just what is x as a number, what is y as a number. So all you need to know and remember is that if you get this question, just look on the graph, where do they cross, read off the x, read off the y. Okay, so you can see here we've got x is 1 and y is 3. It's literally as simple as that. You just have to know what you're looking for, right? Now that you know that, every question should be really straightforward, some easy marks to gain in your exams, okay? Okay, the next one is similar, but as you can see now, we have got a linear graph, a straight line graph, and a quadratic, okay, an x squared. Now, this is technically more so leaning towards higher tier, however, the logic is still the same. Now, obviously, if you are a higher tier student, you will have seen the video we did on solving quadratic simultaneous equations. And we know that, not even just with quadratic simultaneous equations, but just quadratics in general, when we solve them, we tend to get two pairs of solutions, right? So two lots of x, two lots of y. Now, if we take the same logic we had in the previous questions, you can kind of get an idea as to why. So you can see we're looking for obviously values of x and values for y that they share in common. Now, in this case, you can see there are two places where they intersect, where they cross over each other. So that's where we get our two different values of x and our two different values of y. Okay, so in this case, you just have to look for both of them, okay? Make sure you write down all four answers, not just an x and a y. Write down two x's and two y's. So in this one, we can actually see it quite clearly. So if I just look at the top one first, you can see that x is 1. So x is 1 and y is 4. And then the other one, we can see over here, we've got x is, again, don't forget if it's a negative, we've got -2 and y is 1. Okay, it's not really much more work, right? You're literally just making sure you write down both points of intersection, but it's the same logic. So a linear sequence, every time the difference between the terms is the same. Linear just means effectively it's n to the power of 1, something n plus or minus something else. So let's say if I write it like this, we've got a n plus or minus b. Let's say if we write it like that, where basically we just need to find out what is a and what is b. So the first thing you're going to do is you're going to check the difference between the terms. Now, like I said, it should be the same if it's a linear sequence. So you can see here, the difference between 3 and 7 is 4, isn't it? And then the difference between 7 and 11 is also 4, and it should be the same every time. Yep, that's also 4, and 15 to 19 is also 4. Now, this is the common mistake that people make. They go, oh, well, we're kind of adding 4 every time, so I just need to do something n plus 4. That's a mistake. That's not what we want, okay? Because then you can't really figure out what goes in front of the n. It just doesn't work out. Now, I know the difference is 4 every time, but we're not adding 4. Whatever your difference is, don't put it as the plus or minus, put it in front of the n. So I'm going to write it here. So we've got, in this case, 4n. A lot of people don't really know what n is. Well, n is just the number of the term in the sequence. What I mean by that is 3 is the first term in the sequence, isn't it? 7 is the second term. And we say the nth term because the sequence could technically go to infinity, couldn't it? So we don't know what n is. We don't know what it goes up to. So n is just the term number in the sequence, okay? The first term, is it the second term, is it the third term, whatever. Now, if you think about, if I multiply something by 4, that gives me the 4 times tables, doesn't it? And the 4 times tables, well, every time the difference is 4, obviously. So write down this bit, 4n, and therefore write out the 4 times tables. So we've started here, we've got 4n. Okay, if I do 4n for the first term, I get 4, right? 4 times 1 is 4. However, I obviously don't want 4, I want 3, don't I? So then you just say, okay, well, I've got 4n, which is for the first term, 4. How do I get back to 3? This is now when we figure out the plus or minus part. How do I go from 4 to 3? So check, and again, it should be the same every time. From 4 to 3, I have to minus 1, don't I? Double check that for the next one. If I'm currently at 8, how do I get back to 7? Yeah, I minus 1, don't I? Same thing, just double check it works for all of them. So my final answer, when they ask for the nth term, they're basically kind of asking for like an expression, aren't they? Well, we've got 4n and then minus 1. That is your nth term. This is the formula for compound interest. I've obviously written it in my own way. If you prefer to use different letters or write it in a different way, that's absolutely fine. It doesn't matter as long as you can remember it and put the right numbers in the right places. It doesn't matter what letters we use. This is just what I went with. I've written the initial amount. We then times it by 1 plus the interest rate over 100. So basically what this means here is just like the decimal version of the percentage, right? Because you know how percentages, when we use a calculator, we actually have to put them into a decimal format. So you don't necessarily have to use this fraction as long as you're happy with literally converting any percentage into a decimal. Just do 1 plus that percentage, okay, as a decimal. Then this bit here, just the bit here with the 1 plus the percentage, is to the power of the amount of time. Most of the time this is in terms of years. So as you can see, I will have the formula on each question. Now, saying that this is the compound interest formula, I just want to make it clear, this is the formula that will give you what we call the value of the account at the end of, whatever the amount of years it is. It won't tell you what interest has been added on its own. It will give you the value of the account. So that means whatever they've first invested plus all the interest added. So, in this context, Jane invests £3,000 into an account paying compound interest at a rate of 2% per annum. Per annum just means per year. It's just a fancy way of saying that, basically. So 2% per year. Okay, what is the value of her account after 4 years? So, what we're looking for, if you look at this formula, there's 3 bits that are missing, aren't there? The initial amount, the percentage interest rate, and the time. So all you really need to do in terms of this question and the way that it's worded is pick out those 3 things, okay, and just put it into the formula, put the formula in your calculator, because this will be a calculator question, and then write down the answer. So if we were to match it up, for example, we've got the initial amount, which in this case is the amount they're going to invest. So we're starting with £3,000. We're going to have the rate or percentage interest, whatever you want to call it, which is here, and then we're going to have the time, which is this one, 4 years. So all I need to do in this case is write down, obviously I know you're going to put it in your calculator, but also write it down so you get the marks for the working. 3,000 times by, now if I'm to copy this exact formula, it'd be 1 plus 2 over 100, because that converts it to a decimal, and then to the power of 4. Now you can see again, the power of 4 is only for this bit here, it's not the whole thing to the power of 4. You can do either of these, it's whichever you're comfortable with, but these are the same thing. So that would be £3,247.30. So £3,247.30. Now the reason why I said earlier that's the value of the account is because clearly this is what's in Jane's account after 3 years. Obviously still, the 3,000 is still there. And then anything that's beyond £3,000 is obviously then the interest. So that's why you have to be really careful. Double check your question. What have they asked for? In this case, yeah, they've asked for the value of the account. So this is your answer. £3,247.30 is your answer. Okay, so you can see here we've got exactly the same question. Jane, we've got £3,000, we've got 2% interest, we've got 4 years. However, the question now says, how much interest does she earn? So in this case, it's kind of an extra step. You have to use this formula to give you the value of the account. So obviously I know we already did that. Okay, so that was the value. I've just copied that from the previous page. So that's the value. of her account. To find the interest though, you kind of have to do an extra step, and you have to basically take this and just subtract the initial amount. So we're going to do 3,247. I mean, you can probably see the answer from here, but just for the sake of getting the working out marks, write it down. Minus 3,000, which was our initial amount. Obviously, that's going to leave you with £247.30. That is the interest across all 4 years, all added together. That's what Jane earned in terms of interest. So I've put the formula here. It looks basically the same as the compound interest formula. The only thing that's now different is the symbol, because interest is increasing. When we've got compound interest, we're increasing the amount of money we have. When we've got depreciation or compounding, when we're in a decreasing scenario, obviously we need to decrease the answer. So it's going to be subtract instead of the add. Otherwise, all the numbers are pretty much the same. So they don't tend to mention anything about compounding. So it's not as obvious as the compound interest questions are, because obviously those ones say compound interest per year and so on. This one you just kind of have to figure it out and pick up on the clues. So for example, normally it will either be some kind of asset. So what we mean by an asset is something that you can own. So for example, like a car or a boat, could be even a house maybe. I guess like an object really that would lose value over time. So the more you use a car, the less it's going to be worth, right? Obviously. Or the other scenario that you might see is something about a leak or the rate at which water comes out of a pool or out of a water tank or something like that. So again, it's still decreasing. And the point is we have some kind of rate, some kind of percentage per year, month, hour, day, whatever it is. So here we've got a car cost £15,000 when new. The value of the car decreases at a rate of 12% per year. What is the value of the car after 8 years? So if you have a look at this carefully, hopefully you can kind of pick out that we've still got those 3 pieces of information that we look for when we go for compound interest questions. Because we've got an initial amount, so a starting amount, or a starting value in this case, a percentage rate, and we've got a time frame. Only the thing you've got to be aware of is it says obviously decreases, right? So that's where we've got the minus rather than the plus. So in this case, if I know, oh yeah, this is the same as like compounding, I can use the formula. So I've got my initial amount as 15,000 times by 1 minus, in this case, the percentage over 100, or just convert it into a decimal yourself, and then to the power of the time. In this case, because it's 12% per year, for 8 years, I can put 8. Then I would just put this into the calculator. Okay, and it says what is the value of the car after 8 years, so you just write down this new value, which is £5,394, and I'd probably round it to 2 decimal places because it's money, 52. And that would be your answer. So before we jump into any questions, this is basically the most key part of the whole proportion topic. If anything, these are the 2 formulas you just need to memorize. It is in the syllabus as proportion in terms of like ratio and proportion, but technically it is just algebra, right? We're just substituting, rearranging equations, solving equations, things like that. So this is our starting point. As you can see, I've put both direct and inverse proportion here. So we've got here, if you have a question that says, and obviously I've used y and x, but they could be any letters in the question, right? It could be any letters. Y is directly proportional to x. Therefore, the formula I need is this, y equals kx, or in other words, k times x. Now, k most of the time just represents what we call a constant. It's just a number. We're going to find out what that number is depending on each individual question. So the next one has been written differently. We don't have a table anymore. However, you can see the 3 sentences in the question actually line up with the 3 steps that we're going to take, which is really good. Y is directly proportional to x. When y is 4, x is 8. And the question is, find the value of x when y is 17. Okay, cool. So step 1 lines up with this one, doesn't it? Y is directly proportional to x. That means, what is my formula? If it's directly proportional, we've got y equals k x. Y equals k times x. Step 2 is we're going to use our matching pair, so we've got y is 4, x is 8, to find the value of k. So I'm going to take my formula and I'm going to substitute in both of these values. So where it says y, I'm going to put 4, and where it says x, I'm going to put 8. Again, that's kind of just like writing 8k, isn't it? And then I just have to solve this equation, right? So I'm going to have to divide across by 8 because I just want k on its own. K equals 4 divided by 8, which is a half. The k value is going to be different for every single question. And before I get on to my step 3, I'm going to write a little therefore up here. Therefore, I'm going to rewrite my formula, but instead of writing k, I'm going to write the actual number. So I know therefore y equals a half x. So that's my actual formula. So step 3, answer the actual question. As you can see, that's our third sentence here. Find the value of x when y is 17. Okay, we're back to substituting. I'm going to use this formula. I know that y is 17, so instead of y, I'm putting 17 equals a half x. And now I just need to solve this equation. Now, if you've written it like this, 1/2 times x, well, that means I just have to divide by a half, doesn't it? You might have written it differently, though. You might have written it as y equals x over 2, which is fine, in which case you're going to just multiply by 2, aren't you? Dividing by a half is the exact same as timesing by 2, so it doesn't really matter which of these you're going to use. So 17 divided by half is just double 17, which is 34. So there's our answer. So today we're going to be focusing on the formula y equals k over x, which is for inverse proportion, okay? So inverse proportion is where there's a relationship between y and x, but it's kind of going in opposite directions. For example, if y increases, x would decrease, and vice versa. If x increases, y would decrease. So this y equals kx is the formula you need to memorize, as well as obviously the other one for direct proportion. This will be our step 1, our starting point for each question. This one now you can see we're starting to get a little bit more complex, as it's not just y and x, it's y and x cubed. So really pay a lot of attention to detail in these questions. So we're going to do the exact same thing. Step 1, y is inversely proportional to x cubed, which means I need to write down my formula. So I know it's inverse, it's y equals k over x, but it's x cubed this time, isn't it? It's not just x. Okay, so don't forget that, cubed. Step 2, find k by using my matching pair. So when y is 2, x is 5, so 2 equals k over, now it's not just 5, it's going to be 5 cubed, isn't it? So I need to work out, what is 5 cubed? 5 cubed is 125, so I get 2 equals k over 125, and then I just need to times across by the 125 as normal, don't I? Then I get k on its own. Okay, so let's just bring that up over here. 2 times 125 is 250 equals k. So you can see k could be any value. It could be a really small value, it could be a fraction, decimal, it could be a massive value. It just really depends on the proportion relationship. So we're going to do our little therefore. What is my actual formula for this question? Well, y equals, instead of k, I'm going to write 250 over x cubed. So there's my formula. And now finally, step 3, answer the actual question. It says, find the value of y when x is 10. So y equals 250 over 10 cubed. Okay, 10 cubed is 1,000, so 250 divided by 1,000 simplifies as a fraction to being 1/4, doesn't it? And that's it, y is 1/4. So if you found these questions helpful, definitely check out in the description. I'll have links to all of the full videos for each of these topics. If you are doing higher tier, make sure you also go on to the next video to check out the higher tier only content as well.